Hello, everyone. We are Jimmy Holcomb and Lucas Marchant from Central Oregon Community College. This is our capstone project for the COCC GIS program, which was overseen by Program Director Patrick Kennelly. The project started as a sustainability initiative attempting to map student density around campus so we could focus waste collection near high density areas. The data we were given had attendance for each class every hour of every day for 2019. That was pre-COVID. About halfway through the term, the administration approached us with a request that we integrate their recently collected socially distant room capacity data with our student density maps, and if possible, create a tool for querying that data. We were able to create an application that provides multiple means of investigating records to determine which and to what degree classes need to be restructured for the pandemic era. To start, Lucas is going to give an overview of the data formatting used to integrate the data into the web app.
Thanks, Jimmy. Today, we wanted to make a time-enabled application so that the administration can look at the 2019 event records for any time span. And we had all of the event and registration data in Excel format, and then all of our room layouts and footprints within our geodatabase. And the first problem that we encountered was the one-to-many join relationship between the rooms and the events, that we sometimes had several hundred, even up to 1,000 events for the same room over the course of the year. And we didn't want to necessarily summarize this data because, again, we wanted to have a time-enabled way for the administration to filter through it. And so one of our professors, Mike Rich, suggested that we look into the Make SQL Table tool, which proved to be what we needed. It's a way of joining tables based upon SQL statements. And if one of the tables has geometry and coordinates, then the joined records are rendered upon the map, right, on the map viewer. And if the join is a one-to-many join, like the situation we had, then each feature is rendered on the map, one on top of the other, almost like a stacked feature. So you will have several hundred events, several hundred records with the same coordinates and geometry sitting one on top of each other. And so after exporting this temporary feature over to our geodatabase, we're able to shuffle through these stacked features using the time slider and pull up records to the top and display based upon when they happened as well as where. So at this point, we had what we needed for our initial sustainability project, and we're able to map student densities over time around campus. And that is about when the administration came to us with the request to integrate their new social distancing max capacity data. That they had gone around classroom to classroom and surveyed and decided how many students would be allowed within that classroom based upon new social distancing requirements. By joining the social distance max capacity data to our stacked event layers, we're able to introduce a new normalization factor for our student density. That instead of area or seat count, which are traditional normalizations for density on a campus, we were able to map the 2019 attendance as a percentage of the number of students allowed in each classroom according to safety restrictions. And from this map, we made a time-enabled application for investigating data, which I'll speak on in a moment after Jimmy explains our QA and QC process.
Thanks, Lucas. So the data we integrated into the geodatabase came from 3 different sources, all differing in format. The spatial data had been created by a previous capstone class, and the attendance and social distance capacity had been generated by the COCC administration. Among all the formatting that needed to be done, there were 2 large issues that needed to be corrected. In our attendance data, we had a date column, time column, and a date time column. Initially, we were trying to create the time slider using the date time column, but ended up having to cut the date out of the date time column and combine it with the separate time column in order to get all of the instances to populate properly. That saved or added about 1,000 instances in that were then able to connect. Our other large error factor was derived from room naming and abbreviation inconsistencies across our 3 data sources. There were 19 rooms that were improperly labeled, causing the records to go unattached. So once we sorted out proper room labels across the board, we were able to get our linked records to go from 91% to 98%. Lucas will now discuss the problems we encountered transitioning from mass from ArcGIS Pro to ArcGIS Online.
Thanks, Jimmy. So one of the first problems that we encountered going from Pro to Online and then to Web App Builder is that time sliders filter records in the attribute table within Arc Pro, as well as filtering the visualization on the map. And as far as I can tell, this is not the case in Arc Online or in Web App Builder. However, there is the select tool, which is our best option that we use this in combination with the time slider, that if there are records we're interested in, we can select them out and view them within the attribute table. And then the second issue we encountered was that because our records are stacked one on top of another, there's a chance that overcrowded events can be hidden under less crowded events and not appear to the viewer. And so the best way, it's not really a big issue with the hour or daytime sliders, that there's less events within these and more consistent events, but over a week or a term, there's a lot of disparity. And to avoid confusion with this, we encourage using the larger span time sliders in conjunction with the group filter. And I will actually be demonstrating that here. And so we will shift over to a demonstration, and I believe we'll take questions after. So we open the application, and our map populates with layers for a basement and 3 floors, as well as building exteriors. Opening our layer list, we can see that the layers are symbolized on an event's 2019 attendance as percentage of the location's socially distanced max capacity. And looking at this, the first tool we're going to use is a time slider. We have 3 along the bottom for an hour, a day, and a week respectively. And I'm going to use the day slider here and move us forward to the first day of winter term. Now, if we want to investigate a certain room, say for a department planning the upcoming semester, we can open our custom filter down here in the bottom right, and we'll go ahead and activate that and choose which layer we want to filter. We're going to do floor 1 and go ahead and turn off the other layers in the layer list just to clean up our map a little bit. And then we can apply a SQL style selection statement for any of the fields to filter our records. And we're going to go ahead and create one for Deschutes 107. All right, so once we turn that guy on, it brings us down to where it should be, and we find that on Monday there aren't any classes. But if we move forward to Tuesday, we see an item of concern here. Clicking on it brings up a pop-up which shows us that over the course of the day, we had 4 classes over 300% social distance max capacity and 1 at 225%. Moving through the week, we see that same pattern repeat: empty Monday, Wednesday, and Friday, but severely overcrowded Tuesday and Thursday. This is a major opportunity for restructuring, and if this pattern persists, we can recommend to the department that they disperse their courses and thus the student populations over the course of the week. And we can focus our investigation even further using the hour time slider and make more particular recommendations. So I'm going to go ahead and turn our filter off, which will bring us back out. And if we want to investigate the data more generally, we can turn our 4 layers back on over here. Let's see, and look to our column graphs that show the attendance to social distance percentage. And the graph records will filter spatially as we move around the map, and then they also filter temporally with the sliders. We'll move us forward to the second week of term. Looking at our graphs, we can tell a few things. First, that the third floor of the Health and Career Center isn't of major concern, and that the library basement is fairly reliably between 100 to 200% capacity. We can tell that about 10% of our records were 2019 events were under social distance max capacity, and that a majority of the courses were under 200% capacity. We can tell, though, that a small fraction of our courses were over 300% capacity. And if we scan these overcrowded events, we can see that they are concentrated in a few buildings, which may warrant more particular investigation. Switching over to our weekly time slider at the bottom, we can see these estimates confirmed and play out over a larger time span. Let's see. And if we want to export any of our filtered records, we can go up and use our select tool up top here. We will select the desired records. And then from there, you can go over and export or view it in the attribute table. Not sure why that one. There we go. Export as a CSV file or view in the attribute table as you need. I'm going to clear out the selection here. And finally, we can use our group filter to filter records according to the attendance of max capacity. So I'll get this guy up. Here we go. And so we're going to look for courses that are over 200% capacity. We're going to apply it, and you can see it filters out. Now we've got all red on the map, which makes sense according to our symbology. And then we're going to combine this with our attendance per building graphs in the bottom here to identify which buildings are of major concern for us. And we find that on the first floor at least, Deschutes, Cascades, Grandview, and Deschutes, Grandview, and Cascade seem to be of major concern, and particularly overcrowded. And by adding criteria to our group filter over here, we can refine our search to whatever degree is necessary and combine our select tool up top to export all records of concern for further processing. Thank you for your time today, and hope you all please stay safe out there.
We would like to thank Pat Kennelly and COCC for all of their resources and help, and open up the floor to questions. Thank you very much.
Thank you.
Thank you, Lucas and James. I'm not seeing any questions in Slack right now, but we do have time for one question. So I thought I would ask you about your data grooming process, because it sounded like it wasn't perfect from the get-go. What was that like? How'd you deal with that?
So we had roughly 37,000 records, and when we first ran the Make Query table and got those over into a layer where we were able to start working with it, we recognized that we were about 10% short. We only had about 90% of our records mapped. Went back through and surveyed the original CSV document and found that we had several thousand records that weren't being mapped because the time had been set back to the beginning of the century. That in Excel, if it's not a complete timestamp, it gets set back to 1900. So we ended up taking two different columns, excising the date from one and the time from other, and we ended up rehabbing the data quite a bit that way. And then because the layers were made, the building footprints and room footprints were made by a former class, and the administration had changed the abbreviations for about, I think Jimmy said 16 rooms. We ended up having to go through and make sure that the abbreviation of the room, which is what we were joining on, was up to date. And that once we got that done, we had, I think, 98% of the rooms mapped at the end. The only ones were some of the gym buildings we didn't end up having footprints for.
Okay, great.